Hello, my name is Julia, and this is Lab 1 Charged Tape for Physics 2. What we're going to go over is an introduction onto the lab, then some formulas needed for the lab, our steps for figuring everything out, our results, and then the code we use to do a computational model, and then some additional comments. So the introduction is we're exploring the interactions between two charged objects, and this lab, we're exploring tape, which we call U-tape, and representing this using code, our computational model that we used in GlowScript. The formulas we used was Fnet, which is mass times acceleration, Coulomb's law, which is K, which is Coulomb's constant, Q1, which is the charge of the first point, and then Q2, which is the charge of the second point, the unit vector, that is like the vector that represents the distance, usually represented by the observation point minus the point that you're referencing, and then divided by the distance vector, which is the vector I just talked about, squared. And then Coulomb's constant K is approximated as 9 times 10 to the 9. And then we use gravitational force for this, which is 9.8 meters per second squared, which is the gravitational force near the Earth's surface, which is where we were. So some steps are creating the U-tapes, and in order to do that, we took two pieces of tape, kind of put them together, and then completely ripped them and pulled them off of each other, and we did that repeatedly. So you remove the U-tape from the base tape, and then we observed interaction between two tapes. So we took two tapes and we put them together against the table, and then we moved them near each other to see if they would repel or not. Then we tested interaction between the tape and the charged object, which we used a plastic pen that we rubbed in our hair and our clothes, and it repelled. And then we suspended the U-tape shown in this image here, and we positioned a second U-tape below, and you can see that U-tape repelled from the other U-tape. Yeah, and the charged object, it actually attracted. I was wrong. So our results, that both the U-tapes repel each other as shown as this image below, and then they're attracted to our hands and the pen that we rubbed on our clothes and our hair. So some code I have is we represented each of the U-tapes as points, because you can just do a point in the middle of the U-tapes. So our U-tapes were length 25 centimeters. So we converted that to meters, and then our mass was 2 grams or something like that. And so here the red vector showing the electric field from that point as our point of observation, the U-tape above. And as you see, it's going up because it was being pushed up. And then we can show the gravity vector below, showing that it was pointing down. And so those were the forces working off to kind of make it levitate. So an additional comments, any errors. So we assumed that the two tapes had the same charge. Now, that's not always possible, because the more you sit there and rip it, the more charged it's going to be. So if we didn't rip it the same time or rip it exactly the same, they weren't going to have the same charge. And if we touched it with our hands, which is why this is addition to why we don't handle the tape, it starts to lose that charge because it's attracted to our hands and stuff. So messing with that makes it lose that charge. So, the more we fiddled with it, the more likely those charges were to be different. If electrons were positive, protons were negative, I believe that this force would happen the same way, because things attract, and so both of them are currently both U-tapes are currently negatively charged, and so that they would both go into being positively charged, and that still would repel from each other, because they're like charges. And then with the pen would now be negatively charged, and it would still be a negative to positive interaction, so they would still be attracted to each other. Yeah, so thank you for watching.